Good day, dear students. In this video, we will discuss on first, defining a linear inequality into variables. Second, graphing a linear inequality into variables. Third, solving problems involving linear inequality into variables, which were all taken from the module titled Linear Inequalities into Variables by Mersema Balag A. Malanos. So at the end of the lesson, you are expected to differentiate linear inequalities into variables from linear equations into variables, illustrate and graph linear inequalities into variables, and solve problems involving linear inequalities into variables. But before we start with our discussion, let us first compare the following sets of mathematical expressions. We have two sets here. What can you observe on this first set? Very good. All of these expressions has the equal sign. How about for this second set of expressions? That's right. We have here symbols for inequalities. Now, what do we call these mathematical expressions with equal sign? Very good. We call them linear equations into variables. How about this one? If we call these mathematical expressions with equal sign linear equations, what do you think? Can we call these mathematical expressions with linear or with inequalities instead of equal sign? Very good. We call them linear inequalities into variables. So for this video, we will be dealing with linear inequalities into variables. Let us have our first lesson. Defining a linear inequality into variables. When do we say that a given mathematical expression is a linear inequality into variables? So wait a minute. Let's now have our first lesson. Defining a linear inequality into variables. What is a linear inequality into variables? It is an inequality that can be written in one of the following forms. It can be in the form ax plus by is less than c, ax plus by is greater than c, ax plus by is less than or equal to c, and ax plus by is greater than or equal to c. So if you can still remember, if we're going to compare these linear inequalities to linear equations, for the standard form of a linear equation, we have ax plus by equals c. So instead of the equal sign, we now have here inequality symbols, where a, b, and c are real numbers. A and b are not both equal to 0. So one of either a or b can be 0, but not both. Let us now have these inequality symbols and their verbal translations. First, we have here the greater than symbol. So when you see this phrase is greater than, then we are pertaining to this inequality symbol. But if you see is less than, then we have this symbol. Next, we have here greater than or equal to. Take note, it's a combination of greater than and equal to. In verbal translations, we have is greater than or equal to. So it can be both greater than or equal to. We also have is at least, minimum, and is not less than. For less than or equal to, we have is less than or equal to, is at most, maximum, and is not more than. Let us have examples. Determine if the given mathematical expressions are linear inequalities in two variables or not. Let us have this first example. 3x minus y is greater than or equal to 12. Is it a linear inequality in two variables? Yes or no? Of course, yes, it is a linear inequality in two variables because it has the variables x and y with degree of 1. And the inequality symbol is greater than or equal to. How about the second example? 19 is less than y. Correct. Yes, again, it's a linear inequality in two variables because it has the variable y and also with the x, but we cannot see x because its numerical coefficient is 0. But still, it is considered a linear inequality in two variables. How about this third example? Very good. It's not a linear inequality in two variables because it has the equal sign. So it's a linear equation, not a linear inequality. How about this number 4? Is this a linear inequality in two variables? Of course, it's a yes. How about this number 5? 7 times x minus 3 is less than 4y squared. Is it a linear inequality in two variables or not? You're right. This is not a linear inequality in two variables because of this exponent of y. To make it a linear inequality, the degree of x and y should be 1. So it's not a linear inequality in two variables. Now, given the mathematical statement, let us determine the linear inequality or equation described by each statement and determine if it is a linear inequality or not. First, the value of 1 Philippine peso is less than the value of 1 US dollar. So to change this one into mathematical expression, first we have to have P, small letter P. That is the value of 1 Philippine peso. Next, we have is less than. In symbols, that is like this. And then, the value of $1 to be represented by small letter d. So we have small letter d. So that's P is less than D. Now, is that a linear inequality in two variables or not? Of course, it's a yes. Another example. According to the NSO, there are more female Filipinos than male Filipinos. So in this statement, we are comparing the female and male, the number of female and male Filipinos. So we have F and M. It says there are more female. So it should be F is greater than M. So again, this is a linear inequality in two variables. Another example, the number of girls in the band is one more than the number of boys. First, we have to let the number of girls, that is denoted by small letter G, and then we have that is one more than. Take note, is one more than is different from is more than one. Now, it's a linear inequality if the verb is followed by less than or more than. But if we have another word after is before more than and less than, then it makes it not an inequality. So for this case, is implies equal sign. And one more than, so since we use the word more than, that should be written from right to left. So we have one more than is to the left, the number of boys denoted by small letter b. So we have here G is equal to B plus 1, which is not a linear inequality because we have the equal sign. Another example, the school bus has a maximum seating capacity of 80 persons. The maximum seating capacity is denoted by small letter C. Now, when we say maximum, that is already the highest value. Therefore, it has the symbol like this one, less than or equal to. Then we have 80. So C is less than or equal to 80. Again, it's a linear inequality. Next, we have the solution of a linear inequality in two variables. An ordered pair x, y is a solution of a linear inequality in two variables if a true statement results when the coordinates of the ordered pair replace the variables in the inequality. Thus, a linear inequality in two variables has infinitely many solutions. The set of all solutions of the inequality forms the solution set. Like the solution of a linear equation in two variables, like the solution of a linear inequality in two variables, an ordered pair is a solution of a linear inequality if and only if it makes a true statement. So if you substitute the values for x and y and you arrived at a true statement, then it is a solution. Otherwise, it's not. Example, Determine whether each ordered pair is a solution of 40x plus 50y is greater than or equal to 320. First, we have 4, 6. So considering the given inequality, we have 40x plus 50y is greater than or equal to 320. Now, to determine if it is a solution of the given linear inequality, we have to substitute the values of x and y to the given linear inequality. So we now have 40 times the value of x, which is 4, plus 50 times the value of y, which is 6, is greater than or equal to 320. Simplifying the given inequality, we now have 40 times 4, it's 160. 50 times 6 is 300, is greater than or equal to 320. Simplifying further, 160 plus 300 is 360. And bring down 320. So we have 360 is greater than or equal to 320. Now let us determine if that statement is true or false. To determine if the statement is true or false, the point of the inequality symbol should be to the lesser number. So in here, 320 is obviously less than 360. So it points to 320. That means that statement is true, which follows that since we arrive at a true statement, then 4, 6 is a solution of the given inequality. Another example, we have 2, 4. Again, we get the given linear inequality. 40x plus 50y is greater than or equal to 320. By substitution, we have 40 times 2, then plus 50 times 4 is greater than or equal to 320. Always remember that the first coordinate in an ordered pair is the x, and the second coordinate is always the y. And then, multiply 40 times 2, that's 80. 50 times 4, that's 200. Then add 80 plus 200, that is 280. Then we bring down 320. So we now have 280 is greater than or equal to 320. So obviously, in this statement, 280 is less than 320. So the point of the linear inequality should be to the lesser number, which is 280. That means this inequality symbol is inappropriate for these two numbers. Therefore, that statement is false. It follows that the given ordered pair 2, 4 is not a solution of the given linear inequality. Another example, show that negative 2, 3 is not a solution of the inequality y is less than 2x minus 5. Like what we did on our first examples, we have to get the given linear inequality, then substitute. So we now have 3 is less than 2 times the value of x, which is negative 2. So this is our x and this is our y. Minus 5. And then, simplifying the right side of the inequality, we have 2 times negative 2, that's negative 4. Then bring down minus 5. And negative 4 minus 5, that is equal to negative 9. So we arrived at the inequality 3 is less than negative 9. Take note, a negative number is always less than a positive number. So for this case, that is a false statement. Since it's a false statement, then we have shown that negative 2, 3 is not a solution of the inequality y is less than 2x minus 5. Let's now have lesson 2, graphing linear inequalities into variables. But before that, let us describe first the graph of a linear inequality into variables. It is the set of all points in the rectangular coordinate system whose ordered pairs satisfy the inequality. So, like the solution of linear inequalities in two variables, for the graph, we consider here all the points that satisfies the given inequality. We have what we call half planes. These are the two regions in the rectangular coordinate system which were separated by a graphed line. So imagine that we have a line on any part of the rectangular coordinate system, then that line divides the plane into two regions. For linear inequalities, we call them half planes. And that line that divides or separates the plane into two parts is called plane divider. Like this. We call this one the plane divider. And the two parts or two regions divided by the line is called or are called half planes. We have here the steps in graphing a linear inequality in two variables. First step, replace the inequality symbol with an equal sign. The resulting equation becomes the plane divider. So we have to change the inequality symbol in order for us to have or to graph a line which will serve as our plane divider. Second step, graph the resulting equation with a solid line if the original inequality contains the symbols greater than or equal to or less than or equal to. But if the inequality contains greater than or less than symbol, then you use a dash or a broken line. We use solid line to imply that all points that are found on that line are also solutions of the given linear inequality. If it's a broken line, then all the points that are found on that plane divider are not solutions of the given linear inequality. Third step, choose one point in one of the half planes, preferably the point of origin, 0, 0, because it's easier to compute, that are not on the line. Substitute the coordinates of this point into the inequality. If the coordinates of this point satisfy the inequality or make the inequality true, shade the half plane or the region on one side of the plane divider where the points lie. Otherwise, the other side of the plane divider will be shaded. Let us have an example to have a clear view of the steps. Example 1. Graph 40x plus 50y is greater than or equal to 320. So first, we have to change the inequality symbol to equal sign. So from 40x plus 50y is greater than or equal to 320, we now have the equation 40x plus 50y equals 320. Now, if you can still remember, there are different ways on how to graph a line. Since this is already a line. And one of these ways or those ways, and one of those ways is solving for, and one of those ways is using the intercepts. So we have to find for the x and y intercepts. To find for x-intercept, we have to let y equals 0. So substituting 0 to the value of y, we now have 40x plus 50 times 0 equals 320. And then 40x equals 320. Dividing both sides by 40, we now have here x equals 300 divided by 40, that is 8. So our x-intercept is at 0.80. Now solving for the y-intercept. To solve for that, we have to let x equals 0. So by substitution, we have 40 times 0 plus 50y equals 320. This is 0. Then bring down 50y equals 320. Dividing both sides of the equation by 50, we have y equals 320 divided by 50 is 6.4. Therefore, the y-intercept is at the point 0, 6.4. Now, since we have found the x and y-intercepts, we are now ready to graph the plane divider. Note that since the inequality symbol is greater than or equal to, we use a solid line. This means that all the points that are found on this line are solution sets of the given inequality. So 80 is here because 8 is the x-intercept, and then 6.4 is here. It's the y-intercept. Next, decide which half plane contains the solution set. We're going to use 0, 0 for easy computation. Next, replace x and y in the inequality with 0. So when we substitute x and y by 0, we now have 0 is greater than or equal to 320, and that is false. Since the resulting statement is false, that means the region where the point 0, 0 is located is not a part of the solution set. 0, 0 is here. Take note, it's not a part of the solution set. So since this is our plane divider and 0, 0 is not a solution, then we shade the right side of the plane divider, the upper right side. If we arrived at a true statement for step 2 a while back, then we will shade this region where 0, 0 lie. Take note, the coordinates of every point on the shaded region and on the boundary line are solutions of the given linear inequality. Now, if you want to check your answers, you can easily do that by substituting the values for x and y to the given linear inequality. Note that all the points that are found on the solid line and on the shaded region, you will arrive at a true statement. And a point that is found on the region which is not shaded, you will arrive at a false statement. Let us have another example. graph 3y is greater than 2x minus 6. So again, we have to change the given inequality to an equation. We have 3y equals 2x minus 6. Solving for the x-intercept, we have to let y equals 0. So we now have here 3 times 0 equals 2x minus 6. And 3 times 0, that's 0. Then 2x minus 6. Transpose 2x from right to left. So it now becomes negative 2x equals, bring down negative 6. To solve for x, we have to get rid of this negative 2. And that is done by dividing both sides of the equation by negative 2. So cancel negative 2. What we have now on the right side of the equation is negative 6 divided by negative 2. And that is 3. So the x-intercept is 3 or it's at point 30. Now solving for the y-intercept, again we let x equals 0. So we have 3y equals 2 times 0 minus 6. 2 times 0 is 0 minus 6, so we have negative 6. Then to solve for y, we have to divide both sides of the equation by 3 to cancel 3 on the left side of the equation. So we now have y equals negative 6 divided by 3, that is negative 2. So the y-intercept is found at negative 2 or at the point 0, negative 2. Next, we are now ready to draw the boundary line. Take note, from the given linear inequality, the symbol here is greater than. So we will use a broken line. So we have this one. The x-intercept is 3 and the y-intercept is negative 2. Connecting those intercepts, so we have this line. Next, decide which half plane contains the solution set. As a test point, we will use 1, 2. Take note, 1, 2 is found here. It's on the upper left part of the plane divider. So by substitution, we have 3y is greater than 2x minus 6. Substituting 1, 2, we have 3 times 2 is greater than 2 times 1 minus 6. 3 times 2, that is 6. 2 times 1 is 2 minus 6, so we have negative 4. And obviously, this statement is true. Now, since the resulting statement is true, the region where the point 1, 2 is located is part of the solution set. We are ready to shade the half plane that contains the solution set. Since 1, 2 is on this side of the plane divider and we arrived at a true statement, then the shaded region should be on the region where that 1, 2 is found. Okay, so since we have true for 4, 3 and false statements for 2, negative 3 and negative 3, negative 4, then our graph is correct. Next, we have lesson 3, problems involving linear inequalities in 2 variables. How are we going to apply what we have learned on linear inequalities in 2 variables using problem solving? We have here our first example. Miss Plantita enjoys gardening. Every snake plant she waters requires 0.3 liters of water, and every bird of paradise plant she waters requires 0.5 liters of water. Miss Plantita has a total of 9 liters of water for these plants. If Miss Plantita waters 11 bird of paradise plants, How many snake plants can she water with the remaining amount of water? So to solve this, we have to represent first. Since we are on linear inequalities in two variables, we have to let one variable for the number of snake plants and another variable for the number of bird paradise plants. So if we let S for the snake plants and B for paradise plants, we are now ready to make the mathematical sentence. Now, in making the mathematical sentence, we're going to consider the statement here. Every snake plant she waters requires 0.3 liters of water. And every bird of paradise plant she waters requires 0.5 liters of water. And Miss Plantita has a total of 9 liters of water for these plants. So that means we have 0.3 times the number of snake plants plus 0.5 for the number of bird of paradise plants. So we have 0.3S plus 0.5B is less than or equal to 9. Take note, less than or equal to, since 9 liters of water is the maximum amount of water needed to water those plants. So solution using the inequality, we have 0.3S plus 0.5B is less than or equal to 9. The question is, how many snake plants can she water with the remaining amount of water after watering 11 bird of paradise plants? So we will substitute 11 to B. So we now have 0.3S plus 0.5 times 11 is less than or equal to 9. Multiplying 0.5 times 11, we have 5.5. And then 0.3S, by addition property, we have to add the inverse of positive 5.5. That is done by adding negative 5.5 or subtracting 5.5 to both sides of the equation to cancel 5.5. So we now have here 0.3S is less than or equal to difference of 9 and 5.5, we have 3.5. Then divide both sides by 0.3 to solve for S, that is 11.67. So since S is less than 11.67, thus the answer is 11. 12 does not satisfy the given inequality. Therefore, Miss Plantita can only water at most a maximum of 11 snake plants with the remaining amount of water. So we're going to check our answer. We substitute 0.3 times the value for S, we have 11. Then 0.5 times 11 is less than or equal to 9. So we have 3.3 plus 5.5, that is 8.8. Since 8.8 is less than or equal to 9, then that statement is true, which follows that our answer is correct. Another example. Amanda wants to donate at least 250 pesos in the fundraising project of the SK organization for the senior citizens. So, she sells handmade bracelets for 12 pesos each and necklaces for 25 pesos each. How many bracelets does she need to sell after she had sold 6 necklaces? To solve the problem, we have to represent first for necklace and bracelet. Let X be the number of bracelets and Y be the number of necklaces. And for our mathematical sentence, we have each bracelet costs 12 pesos and each necklace costs 25 pesos. So we have 12x plus 25y is greater than or equal to 250. The inequality symbol is greater than or equal to since the amount is at least. That means a minimum of 250 pesos. Next step, we have the solution. Considering the mathematical sentence, 12x plus 25y is greater than or equal to 250. We will now substitute 6 to y because there are already 6 necklaces that were sold. So that's 12x plus 25 times 6 is greater than 250. And 25 times 6, that is 150. Transpose 150 to the right side or subtract 150 to both sides of the equation. We cancel 150 now. What's left on the left side is 12x, and on the right side we have 250 minus 150 or 100. Now divide both sides of the equation by 12. So we have x is greater than or equal to 8.33. That means Amanda can sell at least or a minimum of 9 bracelets. Now, before we end this video, remember the following things. We say linear inequality in two variables. It is an inequality that can be written in either ax plus by is greater than c, ax plus by is less than or equal to c, ax plus by is greater than c, or ax plus by is greater than or equal to c, wherein a, b, and c are all real numbers and a and b are not both equal to 0. And then, to determine if a given ordered pair is a solution of the given linear inequality, we simply have to substitute the given ordered pair to the given linear inequality. Now, if we arrive at a true statement, then that ordered pair is a solution. Otherwise, it's not. Now, to graph linear inequalities in two variables, don't forget to change first the given linear inequality into an equation. And that will serve as our plane divider. And of course, for our plane divider, we have a solid line if the given inequality symbol is either greater than or equal to or less than or equal to. But we're going to use a broken line if the given inequality symbols are less than and greater than. And then, for testing a point to determine which side of the plane divider we're going to shade, we simply have to use or find a point that is either on one side of the plane divider. Now, if you arrive at a true statement, then you shade where that point is found. But if not, then you shade the other side of the plane divider. And last, to solve problems involving linear inequalities in two variables, you simply have to read and understand the problem first, then represent to make or to determine the mathematical sentence. And then using that mathematical sentence, you can now substitute and find for the value of the unknown. That's all. I hope you learned a lot from this tutorial video. Thank you for watching.